Good afternoon, everyone, and thank you for your introduction. Well, as you all know, automation is transforming manufacturing, but there are still areas where robotics alone cannot achieve full efficiency. Today, I will explain how STEM imaging addresses these challenges by integrating advanced vision technologies to bridge those gaps. We'll also explore how artificial intelligence is enhancing our classification and segmentation tools, making processes more robust, accurate, and efficient. First of all, let's see the context. We are working on a challenging market with some well-known problems, such as seasonal demand increases, the market rules, and we have to be ready to respond to our customers' requests when they need us to. We need scalable systems that can handle these production peaks. Also, unstructured workflows. We work with several products, and it's difficult to have dedicated manufacturing lines for a single product. Our process must manage different SKUs in the same line, and the changeover between these products must be automated. And also labor shortages. We all know how difficult it is to find the staff and the advantages of automation in these processes. So you know well these challenges. These challenges are real, and we built InPicker, the solution for these exact needs. InPicker is a powerful vision-guided robotic system developed by STEM Imaging. We are bringing together the potential of machine vision with the power of robotics to create plug and produce vision-guided robotic system for pick and place automation across industries. It is designed to simplify, standardize, and optimize your manufacturing process. And what can we do with InPicker? InPicker is designed to handle a wide range of robotic picking applications. It can manage simple tasks, such as picking a single box from a conveyor belt, and it can also tackle complex challenges like bin picking, where parts are completely randomly piled inside a container. And the best part, all these scenarios are solved with the same system. InPicker is modular and scalable, which means you can start small and expand as your needs grow. It integrates easily into your existing automation setups, reducing complexity and ensuring flexibility for future upgrades. With InPicker, you don't need multiple solutions for different tasks. One platform covers everything, from the easiest to the most demanding picking operations. Now, we've seen what InPicker is and what it can do. So let's see its main components. InPicker consists of three main components. The first one, the InPicker box, the control unit. It handles real-time data processing to ensure smooth and reliable operation, even in demanding environments. Second one, InPicker Vision, the eyes of the system. It captures the environment with high precision using a 3D sensor and a ready-to-use imaging setup. From the data provided by the camera, the parts are detected and located accurately, no matter the position or orientation. And finally, the InPicker Gear, the brain of the system. It is the software that analyzes the 3D data, detects, classifies, and locates each part, and ensures every pick is safe and precise. This guarantees reliable operation, even in complex scenarios like random bin picking. Let's continue with more characteristics of the InPicker. The InPicker has industrial-grade reliability. InPicker box has worked in many applications with demanding environments in automotive and logistics factories. It has industrial-grade reliability. The InPicker box is manufactured by STEM Imaging in Germany. Also, seamless scalability. With the same InPicker system, you can solve from easy and small-scale operation to the most challenging high-volume applications. Also, the InPicker is hardware independent, compatible with all major robot brands, including ABB, KUKA, Fanuc, Yaskawa, and so on. And InPicker provides simplified administration and monitoring of processes. You can access to all the information of the production directly on the InPicker box screen, and moreover, All the information of the production cycles is saved in a database which can be accessed directly from the InPicker interface. So all your production is perfectly monitored and tracked. The InPicker Vision, as I explained, is the eyes of the application. InPicker is hardware independent also for the camera, so we can use the camera that fits better to your application because well, we can use cameras with different 3D technologies and with different fields of views because it's not the same to do a picking of boxes in a pallet of a height of more than 2 meters or picking small electronic components in a small box of 400 by 200 millimeters. InPicker can do both because it's flexible, scalable, and hardware independent. And let's see more details of the software of the InPicker gear. It is, of course, a factory-proven software. InPicker has been developed by STEMer Imaging during more than 10 years. 10 years in which the software has grown tirelessly on the most demanding production lines, nurturing and growing with the needs of our customers. So if you have a problem, we've probably been there and solved it. It has an intuitive user-friendly graphical interface. So you don't need to be an expert in machine vision or an expert in robotics to configure a picking application with our software. So it's not necessary to write a single line of code. And the Picker supports multiple 2D and 3D imaging methods and deep learning for complex object recognition. Related to the deep learning, the InPicker platform features a specialized module called Intelligence, designed to fully support deep learning workflows. This application is seamlessly integrated into the InPicker environment, allowing users to manage the entire life cycle of a deep learning model without needing external tools. With the InPicker Intelligence, you can label data directly within InPicker. This streamlines the process of preparing datasets for training, especially in industrial environments where precision and speed are critical. The image on the left shows the intelligence labeling interface. With the InPicker Intelligence, you also can train models in a guided and intuitive interface. The application provides tools to configure and launch training sessions, making it accessible even to users without deep expertise in AI. In the image on the right, you can see an example of training with intelligence, where you can track all the key indicators of the model training. And also, inside the InPicker Intelligence, you can test and validate models real time. So you can evaluate model performance using test datasets and visualize results immediately, ensuring the model meets the required accuracy and robustness. Once trained and validated, these models can be deployed directly into the InPicker Assistant to use them in the robot guidance applications, enabling intelligent decision-making for tasks such as object detection and classification. This tight integration reduces development time and enhances flexibility. Now let's look at how deep learning is applied within InPicker. On this slide, you can see two real examples of what our deep learning model can solve. On the left, we have an object detection scenario. Here, deep learning segments different boxes from a 2D image. Once the objects are identified, the system combines this information with the 3D image to provide the robot with precise coordinates for picking. This is essential for application with parts without 3D CAD, like boxes of different sizes, or picking natural objects that are close together or partially overlapping. On the right, a second example, an example of classification in the palletizing application. In this case, deep learning recognizes what is currently under the camera, whether it's a layer of boxes, a pallet, a cardboard separator, and so on and so on. This allows the system to understand exactly what the robot is about to pick and handle each element different. For example, the robot can apply different clipping strategies depending on whether it's a box or a separate. In short, deep learning brings intelligence to the picking process, enabling accurate detection and classification even in complex environments. And because this capability is fully integrated into InPicker, you can deploy these models directly with external tools, making your automation smarter and, and more flexible. Now, let's take a look at the future of InPicker. Very soon, we will release a new version packed with advanced capabilities that use the full potential of artificial intelligence to deliver even greater benefits for logistics applications. These features extend the platform beyond standard robot guidance, adding advanced processing and intelligence. The first example are the custom actions. This is a new processing layer on top of pick and place. It allows you to create your own scripts inside InPicker for tasks such as parcel identification, barcode reading, or quality inspections. The key advantage is that everything runs within the same environment. So no external tools or complex integrations are needed. Second, model preselection for environment awareness. The system can automatically recognize what is under the camera, whether it's a layer of boxes, an interlayer, or a pallet. This enables differentiated handling strategies, which is critical for applications like the palletizing, where multiple objects types appear in the same workflow. Third, the segment any box model. This is a teach-less box detector that uses deep learning to segment cardboard boxes without manual setup. It significantly reduces configuration time and improves flexibility for logistics operation. And finally, enhanced robot calibration. We added a 4-axis calibration assistant that simplifies the alignment between the robot and the vision system. This ensures accurate position and repeatable precision even in dynamic environments. In summary, these AI capabilities make InPicker not just a vision-guided picking solution, but a complete intelligent platform capable of adapting to complex scenarios, reducing setup time, and improving overall process reliability. Now let's wrap up everything we've discussed by looking at the 6 key steps of a complete picking process. The first step, the scene capture with our InPicker Vision. We start by capturing the workspace with advanced 2D and 3D imaging, ensuring high-resolution data for precise analysis. In the second step, the 3D environment mapping, we create a comprehensive map of the environment, detecting obstacles and understanding the full layout of the workspace. The step 3, the part detection, where we identify each part with precise position and orientation using multiple detection methods, for example, deep learning, to handle different scenarios. Step 4, intelligent grip point selection. Once the parts are detected, the system calculates optimal gripping points, offering multiple options to guarantee safe and efficient handling. Next step, the part extraction and placement validation, where the robot executes the pick and validates the placement, ensuring accuracy and reliability through the process. And finally, we track performance data in real time and enable continuous process optimization, keeping your automation efficient and under control. In short, InPicker covers the entire workflow from capturing the scene to monitoring the production, delivering a complete, intelligent, and scalable solution for robotic picking. Of course, InPicker delivers clear benefits across your production. It boosts efficiency with continuous 24/7 operation, consistent cycle times, and reduced manual handlings. It improves quality through repeatable precision and lower error rates, ensuring consistent part handling. And it enhances safety and operations by minimizing workplace injuries, reducing labor dependency, and creating a protected work environment. And all this supported by the excellent infrastructure of STEMer Imagine and its technical competence center. 7 engineering teams with more than 60 engineers working in Europe and America. InPicker is a global product with local support. So do not wait to increase the efficiency of your processes with InPicker. Thank you. And now it's time for your questions.
Thank you, Adrian, for introducing us to InPicker. And looking at the time, I think I will start with the first question. Can a single InPicker system guide more than one robot?
Yes, absolutely. For example, InPicker can connect to a PLC, which then distributes the calculated coordinates to all the robots. However, it's important to note that InPicker processes requests one after the other, meaning the robots work in sequence. So if you need to calculate picking positions in parallel at the same time, you would require 2 InPicker units to handle simultaneous requests.
And is the software scalable depending on the complexity of the application?
Yes, of course. The software is fully scalable depending on the complexity of your application. With InPicker, you can start with a basic setup and expand as your needs grow. For example, you can add advanced features like deep learning for object detection and classification, or integrate custom actions for quality checks and barcode reading, all within the same platform. And because InPicker is hardware independent, you are free to choose the camera and the robot that best fits your application without limitation. This flexibility ensures that InPicker adapts to both simple and highly complex picking scenarios while keeping integration straightforward.
Mm-hmm. And is InPicker capable of training its own deep learning models?
Yes, InPicker is fully capable of training its own deep learning models. This is possible thanks to the intelligence module, which is integrated directly into the InPicker platform. With intelligence, you can manage the entire life cycle of a deep learning model without external tool. You can label your data, train your models, and test and validate models in real time to ensure accuracy. So, and once trained, these models can be deployed immediately into the InPicker Assistant, all within the same environment.
So it's also a sign that STEMer Imaging is not only a distributor, it's also a solution provider.
Yeah.
Clear sign. Okay. And what types of industry does it already work in InPicker? Or what is it planned for?
Well, InPicker is a system tested and validated in real production environments. In fact, it has grown directly on production lines since its creation over 10 years ago. Every improvement we've implemented comes from real needs in some of the most demanding industrial processes. Today, InPicker is proving its value in hundreds of installations across different industries, including automotive, logistics, and many others. This track record demonstrates not only its reliability, but also its flexibility to adapt to diverse applications and different industries.
I will talk with my colleague, Frauke Itzeroth from the Robotics and Production magazine, just to make sure that you know about these solutions. So, Adrian, thank you very much for your presentation.
Thank you for your time.